Today you will be creating and interpreting bar and pie charts using categorical data. A bar chart displays the distribution of a categorical variable. Things when you are creating bar charts I'm looking for a title. We are looking for a horizontal label and a vertical label. Space in between the bars. Our bars are nice and shaded. Notice we have category labels, and we also have a consistent vertical scale. If I choose to go by 200s, I have to continue to do so. If I ever see this word relative, that signals my mind we, instead of counts, we use percentages. Pie charts. Pie charts display variables as parts of a whole. They must have a title, so we're talking about customer satisfaction this time. Notice we have our labels: very dissatisfied, very satisfied, somewhat satisfied, and somewhat dissatisfied. Notice how each of our pie sectors is nice and shaded in a different color, and our percentages must add to give me 100%. Next, we want to create a bar chart with the information about those aboard the Titanic. First thing we need to figure out, we need a title. We are going to title this People Aboard the Titanic. We also need a horizontal label. I'm going to title our categories as class, and a vertical label. We can use counts, we can use frequency, it doesn't matter. Notice we also need to determine what kind of scale we want to create our bar chart with. If we have our smallest class is second class 285 and our largest is 885, doesn't really matter what scale you go by as long as you are consistent. So if you wanted to go by hundreds, you can. And then you're going to take your first category first. I'm going to draw it approximately 325 high. And then we're going to shade it in. Okay. And continue doing so with the rest of our categories. Here is a completed bar chart, similar to what we started constructing. Notice you have your title, passengers aboard Titanic, class, and frequency as our labels. Notice our scale is going by 100s. It's nice and neat. We have each of our categories with bars as tall as what is stated in our table, and they are also nice and shaded in. Next, we will create a pie chart with the information about those aboard the Titanic. Creating a pie chart is a little more complex. First thing we will do is we will find the total number of people that were aboard the Titanic. If we were to take our first class plus our second class plus our third class plus a crew, we learned that there were 2,201 people aboard the ship. Now, remember, a pie chart displays the percentages rather than the counts. So I'm going to create a percent column, kind of a frequency / relative frequency table in one. And if you've forgotten how to calculate percentages, we will take 325 and we're going to divide by the total and then multiply by 100 or move our decimal point 2 places to the right. If this should give me about 15%, and we'll continue doing so down the column of the table. So notice we have our percent column from our table. So first class passengers was 15% aboard the ship, second class 13% aboard, The third class passengers, 32% of people, and the crew members, 40% of all people. So that takes care of our percentages. Now we need to figure out what angle to draw our sectors at using a protractor. Because the pie chart is a circle, remember from back in the day, geometry, there are 360 degrees in a circle. So we take our percent times 360 to get our angle. So for first class passengers, we have a 54-degree angle to draw our sector for the pie chart. So notice we have a cute, adorable protractor there. We eyeball the center of the circle and draw its radius. If I wanted to construct the first angle, we have to ask ourselves, is 54 an acute angle or is it obtuse? Well, because it is less than 90 degrees, 54 degrees is a cute and tiny angle. So I'm going to use the numbers, the lower numbers on my protractor, because I can tell it's going to give me an acute angle. I'm going to take my pencil and I'm going to approximately mark where 54 degrees is, and then I will line up my protractor with my dot to draw a straight line. We would write our first class in our label and then the percent. Okay, just like we did before, we will also title it. People aboard Titanic. Okay, and now we're going to continue to the next sector of our circle. Okay. If I look at second class passengers, we found that 13% of ticket holders were third class. 13%, uh-oh, I have a typo. That makes me sad. It should be 13. 13% of ticket holders were first class. If I were to take 0.13 times 360, that gives me my 47 degrees. So I'm going to line my protractor up so that's on my newly created radius and go through the same process. Here is our completed pie chart. Notice we have everything that we were looking for. We have a title, people aboard the Titanic. We have our category labels, first, second, third, and crew. And we have our appropriate percentages. And the pieces of the pie are nice and shaded in. Other useful information when we're looking at data displays, we have this thing called the area principle, and all it states is the area occupied by each part of a graph should correspond to its data. So small areas should have a small value. A large area should have a large value. Okay, so if we look at the graphic provided, note there are a couple different things. We have a title, the shrinking family doctor, the percentage of doctors devoted solely to family practice. So notice that we have ratios at the bottom. Okay. And it says we have ratio to population and then the number of doctors. And as we can see, the number of patients per doctor is increasing. And then also note the 27% is significantly larger than the 16 than the 12. So this one we would say is okay. This graphic display is not as nice. So if we recall the Titanic example we just looked at, this display, remember, the area of the ship is quite a bit larger than where it should be. So notice its counts are down here at the bottom, right? And we have our categories along the vertical axis. This graphic leads us to believe that the majority of people on the boat were crew members, when in fact only 40% were crew. Okay. Our eyes see the area taken up by the ship instead of how long the ship really is. So if we wanted to have a better description, the ships need to be about the same width. And here's what we're referring to. This is another poor example by the area principle. I have this pie chart that is three-dimensional, and sometimes we think it's really neat because it looks different, but it makes our pieces of the pie more distorted than they really are. Remember, a relative frequency distribution displays percentages rather than counts of the variables in each category. So the table on the left side is your frequency table. It is in counts. The table on the right side is a relative frequency table, meaning it describes the percentages. A segmented bar chart displays the conditional distribution of a categorical variable within each category of another variable. It treats each bar as a whole, or 100%, and divides it proportionally into segments corresponding to the percentages in each group. Okay, so notice we have a contingency table or a two-way table of class by survival with only the table percents. Okay, our segmented bar chart is shown off to the right. So notice we have our survival category, alive or dead, and then the colors of the bar represents first, second, third, and crew. And we'll get into more depth with segmented bar charts when we do probabilities. But this is what they look like. I have seen them as free response questions on the AP exam. So just to kind of let you know what's coming. Your math humor and your assignment. Enjoy!